Hello folks, welcome back. I'm your host Amit and today we are discussing the majority element problem. So in this we are given an array of size n and there is an element which appears more than n by 2 times and we want to find that majority element. So in this case one of the follow-up here could be solve the problem in linear time and order of one complexity. So the easiest solution what comes to my mind here is to iterate once and try to figure out for every element to create a map and figure out like which of those maps has the maximum size, and one of them would have definitely more than n by 2 size, and we can definitely return that. That would have order of n time complexity, but space complexity is also not constant. It's not order of 1. The other solution for the order of 1 space complexity is to sort these arrays and figure out the middlemost element, and the middlemost element would definitely be, so the middlemost element definitely give us the answer, because whether it is at the end of the array, in the middle of the array, or at the beginning of the array, if it appears more than n by 2 times, then that should give us the correct result. But can we do it better? Can we do it and that's a simple solution. I'm not going to implement it. Then our question is, can we implement it in order of n time complexity and order of 1 space complexity? Okay, so to figure out order of n time complexity and order of 1 space complexity, we are not creating any other copy or anything, and we are iterating only once through this. So how would we do it? Like okay, so let's try to see it. So what we would do is we would keep a variable and assign this first element to that variable. Okay, let's use that variable and assign 3 to it. Okay, then we will check again, like if there is, and we would also like keep a counter of it, right? So let's see the counter, and this counter like found it once. After we reach to the next element, we see if it is the same element or not, and if it is not the same element, then what we would do is we would reduce this count. We would reduce this count by 1, so it would become 0. Okay, and we can say, because till this time, if the count becomes 0, which means that in this portion which lies after this would also satisfy this condition. Condition means there would be a majority element here, which would be our result. Okay, and similarly we can assign the next element to this array, in this case which is 3, and then we can keep increasing the counter, and when we figure out any other element which is not this element, we would reduce our counter, and that way at the end whatever we have in this assigned variable, we would have that as a result, right? We can check like this example. So a would be 3. Okay, let's say a would be 2 here, so counter would be 1, and if we reach here, a would remain 2, counter would become 2. When we reach here, a would become okay, so counter would reduce, it would become 1, and then when we reach here, counter would become 0. Okay, and when we reach when the counter is 0, when we reach the next element, we assign that as 1, right? Here we assign it 1, but now 2 is different from 1, so this counter would again become 0, and then we would get 2, so we would assign 2 to A, and that would be our result. Okay, so this applies for if we have like more than these elements, any number of elements we have, this applies to that. With this intuition, let's try to resolve this problem. Okay, so we would start our result, or we can say this as max element. Okay, or most frequent element, we can call it MF, and we assign it to the first element on this list, right? We start with the first element, and we would have a counter, and this count, that would be 1. Okay, we should also check like if if the base case is like there should be always one element here or not, and yes, it says that there would be at least one element. Okay, so now let's go into loop for the other elements. For int I put 1, I less than num start length, and I plus plus. So we'll put our base condition here. If if our most frequent number, this is not equal to nums of I, we would decrement it. Otherwise, if it is same, then we would increment it. Okay, now if if after decrementing the count becomes 0, we can again start from there, and we would start like this. Count becomes 1, the starting condition like this, and the MF becomes the current. Okay, and whatever is there at the end of this for loop, we would return that as our response. Okay, let's try to execute it. Okay, this is accepted. Let's try to submit it. Okay, we get our result in 1 millisecond, which is nearly 100th of percentile. Thank you guys. See you in the next one.